Assalamualaikum. Hi everybody, my students. We meet again in this online class. We will continue our last subtopic in chapter 2. Okay, today we will discuss about data switching principle and reliability. Before we go further, let's discuss about switching strategies. There are three types of switching. First is circuit switching. Second is packet switching, and third is message switching. For circuit switching, it carries a bit streams, establishes a dedicated circuit, link reserved for use by communication channel, send and receive bit stream at constant rate. Example, original telephone network. So the most common circuit switching is the conventional telephone network. Okay. Second type of switching is known as packet switching. Packet switching involves store and forward messages. Operates on discrete blocks of data. Okay, compare kepada circuit tadi, dia ialah bit stream, yang ni blocks of data, packet. Okay, utilizes resources according to traffic demand, send and receive message at variable rate, various rate. Compared to circuit switching send at constant rate, but packet switching can send and receive message at different rate. Example, internet. So normally when we talking about packet switching, we are talking about the data like internet. Third is message switching. Store and forward messages. Same. No need to establish a dedicated path between station. When a station sends a message, the destination address is added to the message itself. Each node receives the entire message and the information about the destination. Example, local area network. For local area network, it use message switching. Okay. Switching methods in computer network we have discussed just now. For data transfer, different types of switching methods are available. First is circuit switching. Second is packet switching. Third is message switching. Okay. However, packet switching can be subdivided into two, which is datagram, and secondly is virtual circuit network. Okay, let's see some elaboration on this type of switching method. First is circuit switching. Circuit switching network consists of a set of switches connected by physical link. Okay, so dia ada physical. In circuit switching network, two nodes communicate with each other over a dedicated communication path. Okay, so dia ada two nodes communicate with each other over a dedicated communication path. Predetermined path. There is a need for pre-specified route from which data will travel, and no other data is permitted. So only the data from two nodes, when it is connected, the other data is not allowed. Okay, no other data is allowed. Before starting communication, the nodes must make a reservation for the resources to be used during the communication. The nodes ni macam sender and receiver lah. Okay, computer computer sender and computer receiver. In this type of switching, once a connection is established, a dedicated path exists between both ends. Both ends ni inilah the nodes. Okay, the nodes until the connection is terminated. Ni macam kita telefon lah. Okay, macam kita telefon, kita call, then ada dedicated path, kemudian barulah kita bercakap. When we talking, it somehow like we are transmitting the information lah. So we need to connect between the caller and receiver first. There is a kind of reservation for the dedicated link, and then we talking, that is same like sending information, and then after we finish talking, the connection is terminated. Okay, so this is the figure shows the circuit switching. Okay, this is node A, or the sender, or the caller we call it, before sending the message. So a dedicated link need to be established. Okay, for example, from A to B. So once the link is established, then A can send the data to B. Okay, the end systems such as telephone or computers are directly connected to a switch. When A needs to communicate with B, A needs to request a connection to B that must be accepted by all switches as well as by B itself. This is called setup phase, in which a circuit is reserved on each link and the combination of circuits and channels define a dedicated path. After the establishment of the dedicated circuit, the data transfer can take place. The data can be transferred after the establishment of the link. After all the data has been transferred, the circuit is disconnected. Okay, is turned down. Okay, so after finish transfer data, the circuit can be disconnected. So there is briefly description about circuit switching. So circuit switching is common, related to telephone network. Okay, next is packet switching, which is related to internet. In packet switching, messages are divided into packets of fixed or variable size. So packets can be fixed or different size. The size of packet is decided by the network and the governing protocol. The size of the packet will be decided by the network or the protocol. Resource allocation for a packet is not done in packet switching. Resources are allocated on demand. The resource allocation is done on first come first serve basis. Each switching node has a small amount of buffer space to hold packets temporarily. If the outgoing line is busy, the packet stays in queue until the line becomes available. Packet switching method use two routing methods. Okay, two routing methods. First is datagram switching. Okay, what is datagram switching? Datagram packet switching is normally implemented in the network layer. In datagram network, each packet is routed independently through the network. Each packet carries a header that contains the full information about the destination. Okay, so this is important. So each packet of information carries a header that contains the destination. Contains the information of the destination. When the switch receives the packet, the destination address in the header of the packet is examined. Routing table is consulted to find the corresponding port through which the packet should be forwarded. Okay, so this is example of the datagram packet switching. So this is the sender A. It send the data, the packets to B. Okay, so this is the packet. You have 3 packets of data. So packet 1 can go, all these packets have information that the destination is B. Okay, so in this example, 3 will go through this route. Okay, 1 will go this route. Okay, 1 will go this route to B. 2 will go this route. All packets are going to B, but you can use different route because of the availability of the route. Okay, virtual circuit packet switching. Okay, the first is datagram, second is virtual circuit packet switching. Virtual circuit packet switching is normally done at the data link layer. Data link layer. Tadi apa? Datagram. Datagram is implemented in the network layer. So that is the difference between datagram and virtual circuit packet switching. Virtual circuit packet switching establish a fixed path between a source and destination to transfer the packets. It is also called a connection-oriented network. Okay. A source and destination have to go through 3 phases in virtual circuit packet switching. First is setup phase, second is data transfer phase, and third is connection release phase. Setup meaning establish the link, then transfer the data, and then release the connection. This is a virtual circuit packet switching. So this is virtual. A logical connection is established when a sender sends a setup request to the receiver and the receiver send back an acknowledgement to the sender if the receiver agree. Ni macam circuit switching lah. All packets belonging to the same source and destination travel the same path. Okay. So yang ni, all packets travel same path for virtual circuit packet switching. The information is delivered to the receiver in the same order as transmitted by the sender. Okay. So in this case, for example, you have the packet from A to B. So in virtual circuit packet switching, if the packet sending to the same destination from the same source, it will travel through the same path. So all this packet will travel through same pass. Okay, let's say it has P2, so P2 also travel same path as P1 because it is from the same source and going to the same destination. Okay, message switching. In message switching, it is not necessary to establish a dedicated path between transmitter and receiver. In this message switching, each message is routed independently through the network. Each message carries a header that contains the full information about the destination. Each intermediate device receives the whole message and buffer it until there are resources available to transfer it to the next hop. The next hop, if the next hop does not have enough resources to accommodate large size messages, the message is stored and switch waits. Okay, store and wait. For this reason, the message switching is sometimes called store and forward switching. This is message switching, known as store and forward switching. Message switching is very slow because of store and forward technique. However, therefore, message switching is not recommended for real-time application. It's not recommended for real-time applications such as voice and video. Okay, message switching. This is the figure shows the implementation of message switching, sending the message from A to B, from A the source to B destination. Okay, message M, store and forward, wait for the path to be available, and then forward when the link is available. Okay, so that's all for this topic. Of course, for further reading, you can find the information on your own. If you need further information, I can share with you some extra notes that I have in Comm. So that's all. Until then, till we meet again, I will provide some exercise, some tutorial for these topics, this chapter, okay, for your understanding. So that's all. Thank you very much. Thank you very much for your information and for your attention. That's all. Until we meet again, thank you.